66 million years ago, the Earth entered one of the most violent moments in its entire history. Long before humans, long before memory, before even the concept of continents as we know them today, the planet itself seemed to turn against the life it had nurtured for over 160 million years. This was not a quiet ending. It was not a gradual fading. It was sudden, catastrophic, and global. In a geological instant, the world cracked, oceans recoiled, skies ignited, and an entire age was erased. What followed has been described by scientists as one of the closest things to a planetary death event the Earth has ever experienced. To those who study the rocks, the fossils, and the scars left behind, it is as if the Earth split in two and swallowed a vast dinosaur world whole. The late Cretaceous Earth was alive in ways almost impossible to imagine today. Vast river valleys stretched across continents, lined with dense forests, flowering plants, and towering conifers. Dinosaurs dominated every ecosystem, from colossal plant eaters that shook the ground with every step to swift, intelligent predators that ruled the land. Shallow seas cut through continents, teeming with marine reptiles, ammonites, and plankton that formed the foundation of ocean life. The climate was warm and stable, with no polar ice caps and high sea levels that nurtured rich coastal ecosystems. Life had flourished for millions of years under these conditions, evolving into complex, interconnected systems that seemed unbreakable. But beneath this apparent stability, the Earth was storing energy, pressure, and forces that would soon be unleashed with unimaginable violence. Without warning, a massive asteroid, roughly 10 to 15 kilometers wide, entered Earth's atmosphere at cosmic speed. Traveling faster than a rifle bullet, it slammed into what is now the Yucatan Peninsula. In that fraction of a second, the impact released more energy than billions of nuclear bombs combined. The crust of the Earth did not merely crack, it behaved like liquid under extreme pressure. Rock vaporized instantly. The impact site collapsed, rebounded, and collapsed again, carving a crater over 180 kilometers wide. The ground did not just break apart, it flowed, folded, and fractured as shock waves raced through the planet's crust. In regions thousands of kilometers away, the Earth responded as if struck by a hammer. Seismic waves rippled through continents, triggering massive earthquakes and volcanic eruptions. Entire landscapes destabilized, river valleys collapsed, mountain slopes failed. In places where dinosaurs had once roamed freely, the ground split open, swallowing forests, animals, and entire ecosystems in moments. What had been fertile valleys became death traps as landslides and ground liquefaction erased the terrain. To any living creature at the time, the world would have seemed to come apart beneath their feet. The atmosphere itself became a weapon. The impact blasted trillions of tons of rock and debris into the sky, much of it heated to incandescent temperatures. As this material rained back down, it turned the atmosphere into a global oven. For hours, perhaps days, the surface of the Earth was bombarded by falling fire. Forests ignited on every continent. Even areas far from the impact were subjected to intense heat pulses, enough to cook exposed animals alive and ignite dry vegetation. Dinosaur valleys that had once echoed with life were transformed into infernos, their ecosystems collapsing in rapid succession. The oceans did not escape this destruction. The impact generated megatsunamis unlike anything seen in human history. Walls of water hundreds of meters high surged across coastlines, penetrating deep inland. Marine ecosystems were torn apart as sediments were churned violently, burying coral reefs and shallow sea habitats. The sudden displacement of water altered ocean circulation patterns, disrupting the delicate balance that had sustained marine life for millions of years. Food webs collapsed almost overnight. As the fires raged and the ground continued to tremble, another, more insidious phase of destruction began. Dust, soot, and sulfur-rich aerosols filled the atmosphere, blocking sunlight on a global scale. Day turned to twilight, then to darkness. Photosynthesis slowed and then stopped. Plants died first, followed by the herbivores that depended on them, and finally the predators that relied on those herbivores. This was not a single moment of extinction, but a cascading failure of life systems. Dinosaur valleys, once vibrant with movement and sound, became silent landscapes of ash and decay. The temperature of the planet plummeted. What began as a world on fire quickly shifted into an impact winter. Cold, darkness, and acid rain dominated the Earth for years. Fresh water systems became toxic, oceans acidified, devastating plankton populations that formed the base of marine chains. Even creatures that survived the initial blast and fires struggled to find food in a world stripped of productivity. The reign of the dinosaurs, which had endured for over 160 million years, came to an abrupt and violent end. Yet the Earth was not finished reshaping itself. In the aftermath, geological processes intensified. Massive volcanic eruptions, particularly in what is now India, poured vast quantities of lava and gas into the atmosphere. These eruptions may have been triggered or intensified by the seismic energy of the impact itself. The land continued to sink and rise as the crust adjusted to the trauma. Entire regions were buried beneath layers of sediment and volcanic rock, sealing away the remains of the dinosaur world like pages torn from a book and locked beneath stone. In these buried valleys, fossils tell a story of sudden disappearance. Dinosaur tracks stop abruptly. Nests remain unfinished. Bones are found in chaotic deposits, mixed with shattered vegetation and impact debris. These are not the signs of a slow decline, but of a world interrupted mid-breath. The Earth did not simply outcompete the dinosaurs or let them fade into obscurity. It consumed their world in a geological instant, reshaping the surface and rewriting the rules of survival. From this devastation, however, emerged opportunity. With the dominant giants gone, small, adaptable creatures found space to survive. Mammals, once relegated to the shadows, began to diversify. Birds, the last living descendants of dinosaurs, adapted to the new world. Plants evolved rapidly, filling the empty landscapes. Over millions of years, ecosystems recovered, transformed, and stabilized once more. The Earth healed, but it never returned to what it had been before. The idea that the Earth split in two is not merely poetic. The physical evidence shows a planet pushed beyond its limits, its crust fractured, its climate violently reset, and its biosphere nearly erased. The dinosaur valleys were swallowed not by a single force, but by a convergence of cosmic impact, geological instability, atmospheric collapse, and ecological breakdown. It was the ultimate demonstration of how fragile even the most successful life forms can be when confronted with planetary-scale change. Today, the scars of that ancient catastrophe remain. The Chicxulub crater lies buried beneath sediments, invisible from the surface, yet unmistakable in geophysical data. A thin layer of iridium-rich clay circles the globe, marking the moment when the world changed forever. Fossils above and below that boundary tell two very different stories, one of abundance and dominance, the other of recovery and reinvention. 66 million years ago, the Earth did not just end an era, it transformed itself. The dinosaur valleys were swallowed, but life endured in new forms, shaped by the trauma of extinction. The planet we inhabit today, with its mammals, birds, and eventually humans, exists because of that violent reset. The Earth split, the world burned and froze, and from that chaos emerged a new chapter of life. This is not just a story of destruction, but of resilience written into stone, waiting for us to read it millions of years later.